So here POSET. Now what is a POSET? So let us find the following properties. Now if I consider a relation, now what is a relation? In our first unit we have done the relation part. So in POSET also we need relations on some particular set S, or you can say a particular set A also, satisfying the following properties. Okay, wait. So the consider a relation R on a set S satisfying the following properties. Now what are the properties? So first property is R is reflexive. That means the relation R is reflexive whenever you will get some images of R like that X R X for every X belongs to capital S. Now this symbol is little bit different, X R X, and the word is reflexive. Okay, if I ask you what is a reflexive, what is a reflection? So in general words, what is a reflection? Hello? 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 Am I audible?
Yes, ma'am.
Okay. So if I ask you the meaning of the word reflexive or reflection, so what do you say about reflection? Suppose you have a mirror, and if you stand in front of the mirror, you will see the reflection of yourself. That means the same, it is same as you. So here also reflexive means if I have a image like one, then the relation, that means under the image of one under that particular relation R is again one. So that's why I have written X R X, so the images will be like this. So as it is a relation, relations means you have to understand, okay, the elements are of ordered pair, so elements will be of this form, 1 1, or you can say 2 comma 2, or if you take the alphabets, the images will be of this form. So if you have the images of every element of this form, that means 1 1 2 2 A, or you can say B B, that means the see, first and the second are same numbers or the same alphabets, then you can say that that particular relation is a reflexive relation. Okay, is it clear what is reflexive relation? So you must have the same image for the same numbers or same alphabet for the first and the second elements. Now next is R is antisymmetric. So here see the first line, consider a relation R on a set capital S satisfying the following properties. So first property is R is reflexive, that is X R X. So I have already discussed about that reflexive. The elements will be of this form, 1 1 comma 2 2 A or B B C C, like this. Next is the R is antisymmetric, that is if you have an image like X R Y, that means X R Y and Y R X. In this case you will have X is equals to Y. So suppose you have image like 1 comma 2, then another image 2 comma 1, then you must have, this implies that 1 is equals to 2. Okay, so this is the antisymmetric relation. So if you have a two ordered pair 1 comma 2 and 2 comma 1, this implies that the first and the second positions are equal. So this is antisymmetric. So you have to verify whether the relation is antisymmetric reflexive. And the third one is R is transitive. Transitive means what? If X are Y and Y are Z, then you must have an image X are Z. That means suppose you have 1 comma 2, then you have another ordered pair 2 comma 3, then you must have an ordered pair of this form. See, 1 comma 2, 2 comma 3, then you must have 1 comma 3. So if these three conditions are satisfied, then R is called a partially ordered relation. So here I have written then R is called a partially ordered relation, and the set S together with that partial order is called the partially ordered set or POSET, and it is denoted by S, comma, this symbol is less than equals to, but this is only as simple. It doesn't mean less than equals to. It is the symbol for a POSET. Now tell me whether you are clear about the definition of a POSET. Are you clear, all of you?
You explain again
Which one?
transitive.
Transitive. That is, so
Uh,
suppose you have see these are relations, that means the every element are of ordered pair. So if you have 1 comma 2 one ordered pair, then in that particular relation you have another ordered pair like 2 comma 3. Okay, now see this 1 comma 2 and 2 comma 3, that means you must have one ordered pair of this form 1 comma 3, because see here 1 2 then 2 3, that means you can cancel this 2 because 2 is there in the second position, again in the first position, so left is 1 and 3, so you must have an ordered pair 1 comma 3. Now clear?
yes,
Hello?
ma'am.
Okay, so this is all about the definition of a POSET. So first of all, you have to remember to that means for a relation R, it will become a partially ordered relation whenever these three conditions are satisfied. So first of all, you have to verify for the reflexive property. Now tell me what is the reflexive property? Under reflexive property, what elements you have to find? What type of elements or what type of ordered pair you have to find? Hello? Hello?
Yes, ma'am.
Yes, what type of ordered pair
Hello.
you have to, yes. What type of ordered pair you have to verify for this reflexive property?
Yes, ma'am. X R X.
XRX. That means you have to look for the elements like 1 comma 1, 2 comma 2, 3 comma 3, or if you consider the alphabet, you have to verify for A comma A, B comma B. That means first and the second position both are the same elements. Okay. Now clear? Reflexive property. Hello? Now next one is the R is a antisymmetric. Antisymmetric means if you have elements like ordered pair like 1 comma 2 and 2 comma 1, that implies that 1 is equals to 2, or if you have an element of this form, see these are our relations, that's why I am giving you example of some ordered pair. Suppose you have an ordered pair like A comma B, then you have another ordered pair like B comma C, then this implies that under antisymmetric property A is equals to B. Then only you can say that R is antisymmetric. Okay. Now next is R is transitive. That means suppose you have an ordered pair like A comma B, then you have another ordered pair like B comma C, then you must have another ordered pair which is a relation between A comma C. Then only if a relation satisfies these three conditions, then only you can say that that particular relation R is a partially ordered relation and the particular set is known as the partial ordered set or POSET. And the symbol of POSET is first bracket S comma this less than equals to symbol. Okay. Now next is some important examples. So let us see some examples of POSET. So first of all, let us take the set of natural numbers. So set of natural numbers will start from what are the natural numbers? Can you give me one? Can you tell me what are the natural numbers?
1 to 9.
1, 2, 3, 4, 5, 6, and so on. Okay. So all the so the natural numbers are starting from 1, 2, 3, 4, and so on. Now, if I take one forms a POSET, that means the set of natural numbers form a POSET under the relation less than equals to. Now, less than equals to means 1 is less than 2. 2 is less than 3. So, the set of natural numbers form a POSET under the relation. This relation is less than equals to. That means, first of all, I will see that I will verify that the reflexive property. Now, what is the reflexive property? We have discussed in our previous slide what is reflexive property. For reflexive property, I have to check for 1, 1, 2, 2, 3, 3. Okay. Now, as it is less than equals to, so can I say that 1 is less than equals to 1? Can I say that 1 is less than equals to 1? Is it true? Is it true?
Yes, ma'am.
Yes, because why it is true? Because there is a equals to symbol. Otherwise, if I use this symbol, it will otherwise if I use this symbol, it will be wrong. But I am using this symbol which implies that, see, this is a equal sign. Below there is a equal sign. That's why 1 is equals to 1. Or I can say that 2 is equals to 2. So in this case, all the natural numbers are equal to 1 itself. 1 is equals to 1, 2 is equals to 2, 3 is equals to 3. Okay. So first of all, our reflexive property is done. That means every natural number satisfies that property. Now next, let us verify the second property. That means, what was the second property? It was the antisymmetric property. Now for antisymmetric property, I have to check if 1 is less than 2 and 2 is less than 3, then 1 must be less than 3. Are you getting my point? No, what is the antisymmetric property? If 1 is less than 1, okay, see, if x is less than equals to y and y is less than equals to x, then we have x is equals to y. Now, have you understand this second property? Second property?
Yes, sir. Yes, ma'am.
Yes?
Got it.
Yes, ma'am.
Yes.
So, this is the second property and the second property we will call as an antisymmetric property. So, for antisymmetric property, if 1 is equals to some number A, suppose this one I can write like this. suppose 1 is less than a and a is less than 1, then it automatically implies that 1 is equals to a. Is it true? Is it true? The last line, if 1 is less than equals to a and a is less than equals to 1,
Ma'am, it's
then
true.
yes, so 1 is equals to a. So this is your antisymmetric property. And what was the last condition? Last one? Just tell me the name, the last one.
Transitive.
Transitive.
Trans-
So for
Transitive.
transitive property, if x is less than equals to y and y is less than equals to z, then I must have a x is less than equals to z. So let's verify this property with some examples. Suppose 1 is less than 2 and 2 is less than 3. Then I can say that 1 is less than equals to 3. Is it true? Is it correct? Yes. Is it correct? Hello? Am I audible?
yes, ma'am.
Yes. This one is true for
Yeah.
is this one is true for every
Yes,
natural number?
true. It's
This,
true, ma'am.
yes. So that means this condition will satisfied by every natural number. Okay. So this set of natural number under this relation less than equals to will satisfy these three conditions. That means it is reflexive, antisymmetric, and the transitive. So we can say that the set of natural numbers form a POSET under the relation less than equals to. Okay. Now there is one more example. This is like the set of natural numbers under divisibility, that means x divides y. Now if you have the natural number, now you have to verify whether the set of natural number forms a POSET under the divisibility operation, that means divide operation. Now can you verify that? That means you have to verify for the three properties. So what was your first property?
Reflexive.
Flexible.
Yes, reflexive. Now for reflexive, what you have to check? What type of elements you have to check? You have to check for that nature. You are taking the set
Natural
of
number.
yes, natural number. So you have to verify 1 divides 1. Is it true? 1 divides 1?
Yes.
Yes, 1 divides 1.
Yes.
2 divides 2. Is it true?
Yes, ma'am.
Yes. That means if you take any natural number, it will divide itself. Okay? Because if I take 12, 12 is divisible by 2 and 23, it is divisible by 23. Okay. That means every natural number under divisibility satisfies the reflexive property. Okay. So our first property is done. That means x divides x for every x in n. That means x divides x, or you can say every natural number divides itself. Divide itself. So this is your reflexive property. Next, see, next one is next property. What was your next property? What was your next property?
Antisymmetrics.
Antisymmetric. And for antisymmetric, what you have to verify? You have to verify that if x divides y and y divides x, that means x is equals to y. So first of all, let us take one example. Suppose 5 divides a number a. Okay? any number a, and that particular number a again divides 5, then what is the possible condition of a and 5? What is the relation of a and 5?
A equal to 5.
A equals to 5. So also, if x divides y and y divides x, then we have x is equals to y, and this will satisfy our antisymmetric property. Now next, the third property. What was our third property? It was transitive property. Now for transitive property, I have written if x divides y and y divides z, then we have x divides z. Okay. Let us take one example, because these are symbol, it may be difficult for you to understand. So let us take one example. Suppose 2 divides 12. Okay. 2 divides 12 and 12 divide 24. Then 2 divides 24. Is it true? Is it true? If 2 divides 12
Yes.
and 12 divides 24, so we can say okay, 2 divides 24 also. So that means this will satisfy our transitive property. Now see, the set of natural numbers under division satisfies the reflexive property, antisymmetric property, and transitive property. So the three conditions are satisfied. So that's why we can say that the set of natural numbers under divisibility forms a POSET. Now tell me, is it clear, all of you clear about that POSET? What is a POSET and what are the reflexive, antisymmetric and transitive property? Are you clear? All of you?
Yes, ma'am.
Clear? No doubt?
Yeah.
See,
For
these
me,
are,
ma'am. For
yes,
not others.
yes, no, yes. If anyone have any doubt, please let me know. I will explain again. I will try to clear your doubt. Hello? Okay, so I just take that.
Ma'am,
Yes, yes.
it's clear.
Okay. So all of you, I suppose that all of you have a clear that definition, that POSET. So this two examples, and I share some more examples. There are some more examples and this notes in our WhatsApp group. So you just go through this notes, and again, if you have any doubt, I am saying that if you have any doubt, we will discuss in our next class. Okay, let me know if you have any doubt. So for today I'll stop here. So next class again we will have some only one portion left from this topic, so we will discuss. Okay, so okay, now give me your roll numbers. Roll number, wait, take your attendance. Roll number 1. Roll number 1. Hello. Roll number 1.
Present, ma'am.
Roll number 2.
Present, ma'am.
Roll number 1, 2 present.
One is present.
3,
Two
Yes, ma'am.
present.
4, 5,
Present, ma'am.
6, 7,
Ma'am,
8.
roll number
Roll number
two is present.
Hello? Hello? Hello?
Ma'am, we are hearing.
Yes, I because there is some disturbance. I don't know. Let me do one thing. Who is your class representative?
Ma'am.
Or let us do one thing. Last class, all of you are present. I will give the attendance. If someone who is not present, who was not present in our last class, please tell me your roll number. I will add. Or give me your roll numbers in our WhatsApp group.